So let us now discuss problem number 3. A concrete beam section with F prime C, which is equal to 25 megapascal, is 250 mm wide and 500 mm deep. Has an effective depth of 435 mm. It is reinforced with 1,902 mm squared of tension steel. So, meron daw tayo dito na AS, which is equal to 1,902 millimeter square. Fy is equal to 275 megapascal. Use provisions of section 411.3.2 of 2010. So, gagamitin natin is NSCP 2010, detailed calculation. Determine nominal shear provided by concrete. So, hanapin natin yung V sub C natin, considering the following. So, yung unang i-consider natin is we have a VU, which is equal to 270 kilonewton, and a value of your ultimate moment, which is equal to 100 kilonewton meter. So, makukuha natin yung mga values na yan when we are cutting at a distance D from the support, and then magka-cutting section lang tayo para makuha natin yung shear at saka moment at that point. So, pero dito sa problem natin, already given na yung mga values ng VU at saka ng MU. So, for this one, hahanapin natin yung value ng nominal shear carried by concrete or yung V sub C natin. So, using detailed calculation, in computing for your V sub C, since wala naman tayong actual load, so this will be your formula. So you have 0.16 gamma square root of F prime C plus 17, yung steel ratio natin multiplied by yung VU multiplied by D over MU multiplied by BW multiplied by D. So for this one, meron naman tayong given halos, yung gamma natin, that is 1.0. F prime C, given yan. Etong rho W or steel ratio, makukompute natin yan. Lahat naman, given naman, in computing for your VC. Kaso nga lang, for this one, meron lang tayong certain condition na kailangan natin masatisfy. So for this, yung ratio ng VU multiplied by D over MU, that must be less than or equal to the value nung limiting value natin na 1.0. So for this one, meron tayong VU, multiply natin yung distance. So magiging Newton mm over Newton mm. So magkakaroon tayo ng ratio. Makakancel yung unit and then magiging ratio na lang yung answer natin dito. So that is limited to 1.0. So, let's compute for the value of our ratio here. So, yung ratio natin dito, we have yung VU natin na given na 270 kilonewton yan. I times 10 raised to 3 natin para maging newton. Multiplied by yung effective depth natin na 435 millimeter over the value of your MU. So, eto nyan, we have 100 times 10 raised to 6 newton mm. So, the value of our ratio, that is equivalent to 1.17. So, that is greater than 1.0. Kaso nga lang, sabi sa code, hanggang 1.0 lang yung ratio natin dito. So, meaning to say, use 1.0 instead of using 1.17. So, for this, wala na tayong problema sa ratio ng VUD over MU. So, let's compute now for the value of your steel reinforcement. So, in computing for your steel reinforcement, that is only AS over BD. So, let's compute for the value of your AS. So, rho W, yung AS natin, that is 1,902 mm squared all over yung effective concrete area natin, which is equal to BD. So, yung base natin, that is 250. Yung effective depth natin, that is 435. So, you have a steel ratio, which is equal to 0.01749. So for this, meron tayong mga given, makukuha na ngayon natin yung value ng V sub C natin. So we have 0.16, yung gamma natin, that is only a normal, assume natin a normal weight concrete na 1.0. So meron na tayong mga values. So let us now substitute yung mga nakuha natin given. So we have 0.16, 1.0 multiplied by the square root of 25 megapascal plus 17, yung still ratio natin na nakuha natin na 0.01749 multiplied by yung ratio natin which is equal to 1.0 multiplied by yung BW natin which is equal to 250 multiplied by the effective depth of 435 millimeter. So you have a value of your V sub C which is equal to 119.335 kilonewton. So under dito, no, under sa detailed calculation natin, meron tayong another consideration dito. Let us compute for the value of your V sub C. So meron tayong dalawang formula. So yung pangalawang formula natin, that is equal to 0.29 lambda square root of F prime C BWD. So if you are going to substitute yung mga given natin, lambda is 1.0, F prime C is 25 megapascal, BW that is equivalent to 250, effective depth is 435. So the value of your VC is now equal to 157.69 kilonewton. So between the two, so i-adapt natin yung smaller value natin between sa dalawang nakuha natin. So we will adopt the smaller value. Therefore, your VC is now equal to 119.335 kilonewton. So this will now become your answer. Next naman is, what if your VU is equal to 270 kilonewton, you have a value of your MU having the same magnitude of 100 kilonewton meter, and dagdagan natin yan ng axial compression. So the value of your axial compression is equal to NU, which is equal to 180 kilonewton. So using detailed calculation, NSCP 2015, let us calculate for the value of your V sub C. So what will be the formula na gagamitin natin dito? So V sub C, so that is equivalent to, so kopyahin lang natin yung formula natin dito, 0.16 gamma square root of F prime C plus 17 yung still ratio natin multiplied by VUD over, so mag-modify lang yung moment natin dito, multiplied by BWD. So for this, yung condition naman natin dito, yung MM natin, that is equivalent to MU minus NU multiplied by 4H minus D over 8. So that is the formula of modified moment. So para makuha natin yung modified moment natin, so yung MU natin, that is 100 kilonewton, so that is times 10 raised to 6 minus yung actual compression natin, since compression yan, kaya positive yung ilalagay natin. So we have positive 180 times 10 raised to 3 multiplied by 4, yung age natin, that is the total height of your concrete. So in this example, we have a 500 mm concrete beam. So 500 minus yung effective depth natin na 435 mm all over 8. So you have a value of your modified moment which is equal to 64.788 kilonewton meter. And after that, we are going to solve for the value of this ratio. So you have the value of your VU which is equal to 270 kilonewton. So ito times 10 raised to 3 natin para maging Newton. Yung D naman natin or the effective depth, that is 435 mm. And your modified moment, that is 64.788 times 10 raised to 6 para maging Newton mm. So we will have a ratio of 1.81. So etong ratio natin dito, kapag meron tayong actual, pwede yang mag-greater than into 1.0. Okay. So, meron lang tayong restriction na 1.0 kapag without actual tayo. So, therefore, we will going to use 1.81. So, substituting yung mga values natin para sa value ng VC natin, we have 0.16. Yung lambda natin, that is 1.0. Square root of F prime C. So, we have an F prime C of 25 megapascal plus 17. Yung still ratio natin na 0.1749 multiplied by yung ratio natin na 1.81 multiplied by yung B sub W natin na 250, yung D natin na 435. So you have a value of your VC which is equal to 145.526 kilonewton. So besides dito, meron tayong another formula in computing for the value of your V sub C. So ano yan? So tatlo yung formula natin dyan under detailed calculation with actual. So let's proceed to the second formula. So that is VC for detailed calculation with actual. So VC, that is 0.29 lambda square root of F prime C. So magkakaroon tayo dito ng 1 plus 0.29. So that is AG over NU BWD. So next, yung V sub C natin, we have 0.29. Yung lambda natin, that is 1.0. Yung F prime C natin, that is 25 megapascal multiplied by 1 plus 0.29. Yung area gross natin, that is 250 by 500. Over yung NU natin, since compression yan, kaya positive 180 times 10 raised to 3. Yung BW natin, that is 250. Yung D natin, that is 435 mm. So you have a value of your VC which is equal to 172.838 kilonewton. Therefore, if we were going to compare yung dalawa, VC is equals to 145.526 kilonewton. We will going to use the smaller value. So smaller value yung gagamitin natin dito. Kasi as much as possible, nililiit natin yung value ng V sub C natin. So, di ba, yung formula natin is pag ganito. Okay? So, nililimit natin yung capacity ng V sub C natin para tumaas yung value ni V sub S. Kasi kapag mataas yung value ng V sub S natin, mas lalong bababa yung value ng spacing ng stirrups natin. So, kapag mababa yung value ng spacing natin, mas malakas yung konkreto natin or mas malakas yung beam natin in resisting shear sa beam. Okay. Kasi kung mapapansin natin, kung maliit yung value na to, para mabalance natin yung equation, kailangan tumaas yung value ni VS natin. And kung mapapansin natin yung formula natin for that, so that is S is equals to AVFYT over VS tapos dito D. Diba? So kung mas mataas yung value ng V sub S natin, mas mababa yung value ng S natin. So the more na bumababa yung spacing ng stirrups natin, the more na nagiging safe yung konkreto natin against shearing. So that is the reason kung bakit smaller or smallest value yung kinukuha natin pertaining to V sub C.